Section 10.6, just like you've done in the past, after you thoroughly investigated a topic, then you usually said, okay, now how would I solve an equation that incorporates that kind of number or quantity? Like when you studied fractions, maybe back in 301 if you took it. You studied fractions, and then the next thing you know, you're doing equations with fractions. You study decimals, you're doing equations with decimals. We're going to do equations with radicals. Okay, and this is section 10.6. Problem number 1, because I'm going to jump in and write down the first equation. The square root of 5x is equal to 25. Now I want to pause for just a second. Square roots, although we don't talk about this like we did with rationals. When we first started studying rationals, fractions, one of the first things we talked about was their domain, that you cannot have a 0 in the denominator. Okay, so, and when we did equations, we had to make sure if we got that extraneous answer that made the denominator 0, that we threw it away. Okay. With radical equations, there's also domain exclusions. The radicand, well, let me see if you tell me. No matter if it's got a variable in it, what do you not want the variable to cause the radicand to become? Okay, the normal answer is 0, because it was the problem with fractions. Well, what's the square root of 0? 0. Actually, 0 is not a problem. But what do you have trouble taking the square root of?
Itself.
Pardon?
Itself.
No. Not 1. 1's okay.
2.
2's okay. We're good. We could go through all those numbers, and I'd keep saying those are good. Pardon? Okay, I'm going to grab a piece of that, Vic. Negative. What happens if you take the square root of a negative number? You can't. Not in the real numbers. Okay, and for today, we're still looking at real numbers. Tomorrow, we get to invite the imaginaries into the class. But for today, you can't take the square root of a negative number. So if you get an answer and you just check it far enough, or you check it, because of this negative issue, you might get an extraneous solution. Okay, so just kind of keep that in mind. All right, to solve equations with square roots. First of all, you want to get the square root term isolated. Make a little note about that perhaps somewhere. You want the square root isolated. So if there's something added or subtracted, you move it to the other side. All right, now, in solving equations, we always do the inverse of whatever was done. If there's addition, we do subtraction. If there's multiplication, we divide to try to get x all by itself. Well, this has got square root. What's the inverse of square root? Squaring. Squaring is the inverse. So what I'm going to do, now in the future, I'm not going to copy it over, but I will in this problem. I'm going to put the left side in parentheses and the right side in parentheses, and I'm going to square the left side and square the right side. In the video, this does not show up. In the classroom, I do not know why that screen has turned blue, and that makes it a little harder to read, and I'm sorry about that. That's not happening on this screen or this screen. It's that machine. It doesn't like me sometimes. All right. So if I square the left side, well, that is the square root of 5x times the square root of 5x, and what happens? It's 5x. It pops out. The right side, if you square 25, you get a big old number. I think you get 625. All right, it's looking good. Now, you've got a plain old linear equation to solve. There is a possibility that you'll get a quadratic equation. Divide by 5. and x is equal to 125. So I squared both sides. Everything looks good. Now, you need to check it. You really do need to check it. It's not a matter of just, if I put this in there, will I get a negative radicand? Other things can happen. So I always check them. And I have square root of 5x is equal to 25. So the square root of 5 times 125 is, I'm wondering if that's going to be 25. Let's see. That's the square root of 625, which is 25. If the check is not going to work, it will somewhere be a sign issue. Because remember, when you square quantities, you tend to get positives. And you take the signs out of the problem almost. You take the negatives out, and it can cause you to get an answer that won't check in the original. So just kind of be careful. This one is okay. Number 2. I have the square root of x minus 9 is equal to 21. All right, got my equation. Is the radical isolated? Yeah, it is. All right, so what am I going to do to both sides? I'm going to do the inverse, which is squaring. So I'm going to square the left side and square the right side. And I'm being lazy by not rewriting it. When I square a square root, what happens? Pops out. X minus 9 equals, and I'm going to need some help because I don't know what 21 squared is. 441? Okay, thank you. I have a linear equation to solve now. Add 9 to both sides, and I get x is 450. Is everybody okay with that process? All right, let's check it because we need to check this thing. All right, the original problem was square root of x minus 9 is 21. So it's going to be the square root of 450 minus 9, which is the square root of 441, which is 21. Algebraically, I'm kind of cheating a little bit. My format's a little off because I'm not keeping on with the equal sign and so on. But I'm just checking to see if the left side is equal to the right side. Are we okay? All right, let's look at number 3. I have the square root of 5x is equal to negative 7. Is the radical isolated?
Yes.
Yes. So I can square the left side and square the right side. If I square the square root of 5x, I get 5x. And if I square negative 7, I get 49. It's linear equation. Divide by 5. And I'm going to leave it improper as 49 over 5. And I'm going to check and make sure that MathLab is okay with that. It doesn't say, and it does say type in if there is no solution. Okay, but I'll just leave that for right now, but let's check it. Square root of 5x is supposed to equal negative 7. So that's the square root of 5 times 49 over 5. Well, normally multiplying that, I might start saying, oh gosh, what am I supposed to do? No. 5's divide out. I get the square root of 49. The square root of 49 is 7. Are they the same? No. It's because of the squaring process that the equation saw negative 7 as equivalent to positive 7 almost, because either way you square it, you get 49. So it didn't know where it came from. I don't know if that statement actually made a lot of sense to anybody, but this doesn't work. Since that doesn't work, what does work? Nothing. No solution. If we had had a quadratic and we had two answers, one of them might check and one of them might not check. Or maybe both of them check, or maybe both of them don't check. So there's a lot of possibilities. But if you have no answers left, you type in an N. There was an indicator that that was going to happen way up in the beginning of the problem. Can the positive square root of a number equal a negative quantity?
No.
No. So maybe you could see it early. Just be careful, though. Sometimes it's safer just to do the whole thing. All right, number 4. I've got the square root of 3x minus 2 minus 4 is equal to 0. What's that first question I ask you every time? Is the radical isolated? Is it?
No.
No. We've got a minus 4 sitting there. So, plus 4. Add 4 to both sides. And now I have the square root of 3x minus 2 is equal to 4. For those of you in class, I'm so sorry that screen is blue. I know that makes it more difficult to see, but I don't know what it is. It does happen sometimes. All right. What next? Isolate the radical. Square both sides. You don't want that radical, so you have to square both sides. What do I get on the left? 3x minus 2. And on the right, 16. I have a linear equation to solve. Add 2. That gives me 3x is 18. Divide by 3. X is 6. But I need to check it. So, and check, always check in the very original equation. So I have the square root of 3x minus 2 minus 4 is 0. So that's going to be 3 times 6 minus 2 minus 4 on the left, which is 18 minus 2 is 16 under the radical, minus 4. The square root of 16 is 4, and 4 minus 4 is 0. And it checks. So 6 is my answer. We okay? All right, let's look at number 5. I have the square root of 41 minus x is equal to x plus 1. Is the radical isolated? Yes. Okay, so I'm going to square the left side and square the right side. The left side, when I square the square root, radicand pops out, 41 minus x. When I square the right side, this is the first time we've had one like this. The right side is a binomial. You can either remember the squaring process, or you can do that's x plus 1 times x plus 1 and use FOIL. Either way, do what is safe for you, that you will get the right answer. You're going to end up with x squared plus 2x plus 1. It's back to white, isn't it? I do the squaring process because for me it's a mental process because I've practiced it for 100 years. I square the first one for x squared. I look at the product of those for x, but then I double it because that represents both outer and inner for 2x, and then I square the last one for 1. If you do it by FOIL, you get the same answer. Is this a linear equation? This is quadratic. Oh, went back blue, it got mad at me. This is quadratic. And what format do we have to get quadratic equations in? Equals 0. Okay, so I need to do two things. I need this side to be a 0, so I'm going to subtract 41. What else can I do? Add x. I am hopeful that at this point we're okay doing two steps at once. So 0 is equal to x squared plus 3x minus 40. The problem will be rigged at this point in the semester so that it's factorable if it's quadratic. Chapter 11 gives us techniques for solving quadratic equations that aren't factorable. And I want to make sure we do those, but we got to throw it somehow all in on Monday. All right, so I get 0 is equal to, I need 1 plus and 1 minus. I need an x and an x. Factors of 40 with a difference of 3, 5 and 8. So I'll put the 8 there and the 5 there. That works out. What are my two solutions? -8 and +5. And I have to check both of them independently. I know it's a pain to have to do that, but you do. Whoops. Well, all right, I'm going to check x equals -8 in square root of 41 minus x equals x plus 1. That's the square root of 41 minus -8 is equal to -8 plus 1. That's the square root of 49 is -7. In this problem, I am having to simplify both the left side and the right side in the check, but I haven't had to do that in other problems. What's the square root of 49? 7, but the right-hand side is -7, so this one doesn't work. That's not an answer. Did you notice that in the check, the reason the check failed was signs? You'll always see that if you're dealing with an extraneous solution with radical equations. All right, now I need to check, is it +5? X equals 5. And the equation was square root of 41 minus 5 is equal to 5 plus 1. Left side, that's the square root of 36, which is 6. The right side is 6. That one checks. So I got a quadratic equation, I got two answers, only one of them checked. So x is 5. I want to hold off on number 6 for a minute. And I'm going to put down number 7. Like I said, I'm holding off on 6. 7 is the square root of 2x minus 3 is equal to 3. And I would like you to solve it, and I'll pause the recording. Resuming back to math. All right, the radical is isolated. I square both sides. On the left side, I got 2x minus 3. On the right side, I got 9. I'm going to add 3 to both sides because this one is linear. I have 2x is 12, x is 6. Does it check?
Yes.
Yes. Okay, and I'm going to take your word for it. My class says it checks, so. All right, let's take a brief look at 8, which looks a lot like 7. I have the square root of 7x plus 3 plus 4 is equal to 0. Is the radical isolated? No, I need to subtract 4, and I have the square root of 7x plus 3 is equal to negative 4. Anybody want to make a comment?
It's going to be again.
It's not going to work. The square root of a quantity, if it doesn't have a negative sign in front of it, can't equal a negative. Now, if there were a negative sign in front of it, it could. But the square root of something can't be negative 4. So you can stop right there and say no solution. Or you can finish the problem, check it, and find out that it doesn't check. It'll be off by a sign. All right, now I think I promised you, well, I didn't promise you, but I skipped number 6. Let's look at 6. I made sure I did not put a problem like 6 on your test. You'll see why. Oops. It gets a star. It's an exceptionally long problem. Okay. So, square root of y plus 3 is equal to 5 minus the square root of y minus 25. Well, you observe a few things about this problem that you haven't seen in others. You see you have a radical on the left and a radical on the right. That in itself is not really a problem because you could square both sides, they both pop out, everything's good. This radical is isolated. Is this radical isolated?
No.
But if you were to get rid of this 5, it would just go invade the other side. I cannot make both radicals be isolated, and that means I'm going to have a little bit of extra work. So here we go. I'm going to square the left side, and I'm going to square the right side. Left side turns out pretty easy. I end up with y plus 3. Now the right side. You've got to treat it as a binomial. It's 5 minus the square root of y minus 25 times 5 minus the square root of y minus 25. I sure wish squaring binomials was as easy as multiplying conjugates, but it's not. All right, the product of the first. I'm using FOIL. All right, not bad. 5 times 5 is 25. Outer product, 5 times this negative square root is negative 5 square root y minus 25. Am I writing too tiny for those of you in the back? We're okay? All right. The inner product is another negative 5, times the square root of y minus 25. That shouldn't surprise you because when you're squaring a binomial type expression, the outers and inners ought to be the same. What happens when you square the square root? What is negative square root times negative square root? Positive. And what happens to the y minus 25? Pops out. Well, that was just really fun. Is everybody okay with that? All right, it's long. And I think I can probably simplify on that right-hand side. What do you see that we can do? Oh, that's nice. 25s cancel out. And so I'm going to end up with, I've got a y and minus 10 square root of y minus 25. And that's equal to y plus 3. And this problem is not as bad as I anticipated. But it's not fun. Okay. Can you isolate the radical now? Okay, could you subtract y from both sides to get rid of that? That's what I was talking about. It's not as bad as it could have been because that outside y went away. Now, I have 3 is equal to negative 10 times the square root of y minus 25. I squared both sides. That did not eliminate all the square roots from the problem. So guess what? I have to square again. Now, some people, and you're right, the radical is not completely isolated, but it's your choice. Negative 10 is a coefficient. If I divide by it, I end up with a fraction over here. Or I can just square it as is because it's not a problem. You'll square that factor and square that factor. Which way are you inclined to do it? Okay. So I'm going to square the left side and I'm going to square the right side. And remember, when you have a product, all you have to do is square each factor. It's when there's a sum and difference that you have to do FOIL. All right, that's going to give me 9 is equal to squaring the negative 10, you get 100. And squaring this, it pops out as y minus 25. So it's not quadratic, it's linear. I have 9 is equal to multiplying 100y minus 2500 using the distributive property. I'm going to add 2500 to both sides. So I have 2509 is equal to 100y. Okay, both sides, and I don't believe 100 goes in there evenly, so I'm going to leave it as 2509 over 100. Are you excited about checking that? I am. Quit. All right, the original problem was the square root of y plus 3 is equal to 5 minus the square root of y minus 25. All right, I have 2509 over 100 plus 3. I just want to work on the left-hand side for a minute. I need to get a common denominator under there. And what will the common denominator be? What? 100. Okay, so the first fraction stays 2509. 1 goes into 100 times, and 100 times 3 is 300. Still working on this left-hand side. That's going to be 2809 over 100. Would somebody check and see if 2809 is a perfect square? $53. Okay, life is good. Now, the right-hand side. We have 5 minus the square root of 2509 over 100 minus 25. Okay, and this is supposed to be equal. So I have 5 minus, do you agree we need a common denominator again? So I'm going to have 2509 over 100 minus over 100. I'm going to multiply the top by 100 for 2500, which gives me 5 minus the square root of 9 over 100 when I subtract. Perfect square. So that's going to be 5 minus 3/10. I don't think I need to go any further. Is 53 equal to, back to this side, did y'all catch that I left something off? The denominator. I'm so sorry. The square root of 100 was 10. So add that to your problem. Now, and the reason I say that's significant, this isn't checking. This is going to be 50 over 10 minus 3 over 10, which is 47 over 10. Do you see that it could have checked if the sign had been different? If I had gotten to add, it would have checked out. Anytime you've got an extraneous solution and you're going through the check will fail because of a sign. Okay? And that's what tells you it's extraneous. Oh, that didn't work. And that didn't work. We did all that work, and we found out it was no solution. You know, right up here, it was observable, if you were really experienced, that it was going to have no solution. Because the left-hand side was a positive number. The right-hand side was going to have a negative value. Could the negative times the square root equal a positive number? The answer was no. But I would think it probably takes more than one example to have realized that. All right, so solving equations, pretty easy unless you can't isolate, and then it gets involved.